Hi, so today we're going to look at fetal circulation. Fetal circulation. All right. Now, before we can get into fetal circulation, we need to understand and have the background of the normal adult circulation. Now, let me just try to make a simple diagram. So let's say this is the heart. Okay, so this is now the heart here. And we have the chambers like that. So let's say this is the left atrium. This is the right atrium. This is the right ventricle and the left ventricle. Okay. So now we have the lungs here. Okay. So we have the lungs. We have the lungs here, and we have the body tissues here. So here we have the lungs. This way, we have the lungs there, and then we have, of course, the heart, and then we do have the body tissues, the rest of the body, right? The body tissues. Okay. Now, we should understand that normal adult circulation, even though the heart is anatomically one organ, okay, physiologically it functions as two organs. All right. So that is, we have the left heart and the right heart, and therefore we do have what is called systemic circulation and pulmonary circulation. Now let's try to look at that quickly, and then we can look at fetal circulation very well. Okay, so now we do understand that we have what are called, so let's say we have the pulmonary vein, okay, the pulmonary vein like that. So of course, we know that we have the left and right pulmonary veins. So the pulmonary vein, now let me actually draw it in, right? Because we know that all veins carry oxygenated blood, deoxygenated blood, except the pulmonary vein. So I'll draw it to symbolize oxygenated. Okay. So we have something like that. So I'm trying to make that a simple diagram. And then we also have blood leaving the left ventricle. Okay? So blood leaving the left ventricle here. I'm going to try and draw it this way. Right. And of course, there's the valve here, and now we do have a valve. Okay, one something here. Right. So of course, here we also have what is called the pulmonary valve. Okay, right, something like that. Perfect. So here we also have the pulmonary artery. Okay, we have the pulmonary artery here. Right? So here we can see that we're trying to look at what is called pulmonary circulation. So pulmonary, in terms of pulmonary circulation, we see that blood will leave the right ventricle, and then it will be pumped into what is called the pulmonary artery. Okay, and then the pulmonary artery will carry that deoxygenated blood to the lungs for oxygenation. Now, of course, when you look at the lungs, this is where we're going to find what we call the alveoli. Okay, so if we zoom in there, we're going to find something like this, right? And then we see that we have the capillary bed. Okay, we do have the capillary bed there where oxygenation of blood is taking place. Okay, something like that. So, of course, we can see that at that point, oxygen diffuses into the capillary, and then carbon dioxide diffuses out of the capillary. Okay, and then it is breathed out. Okay, so at this point, this is where oxygenation of blood is taking place. So blood is flowing like that, for example, it's flowing like that, and then oxygen, because there is more oxygen in the alveolar space, there's more oxygen than in the capillary, blood passing through the capillaries. So because of that concentration gradient, oxygen diffuses into the blood and combines with what is called hemoglobin, okay, in the red blood cells. So once it combines with the red blood cells, it gets oxygenated, while at the same time carbon dioxide diffuses out of the red blood cells and goes into the alveolar space, and then it is breathed out. And then blood comes back to the heart through what is called the pulmonary vein. Okay, so once it reaches the heart, it will enter the heart through what is called the left atrium. Now, in the left atrium, there, of course, it's not going to stay there. It's going to be pushed into the left ventricle. Now, the left ventricle is going to, what is it going to do? It's going to pump blood at very high pressure. Now, we know that the left ventricle has thick muscle, right? The left ventricle has a thick muscle like that, because it has to push blood at a high pressure to all parts of the body. All right. So oxygenated blood comes in and is pumped out by the left ventricle into what is called the aorta. So here is the aorta. Of course, we know that the aorta somewhere here it makes what is called the arch of the aorta, and then it comes down like that. Right. Now, of course, I'm not going to say those little details. So here we have the aorta. Okay, so we have the aorta there. So blood, oxygenated blood is going to come down the aorta, to the aorta, then to go to all body tissues. Now, the opposite of what is happening in the lungs is basically going to happen at the cellular level at this point. So here, what is happening is that if this is these are body tissues, right? If these are cells of the body, and then we have a capillary carrying blood like that. Okay, so this is that is blood. So the opposite is happening at this point. Okay, oxygen is leaving the blood going into the body tissues. Okay, so this is oxygen, and then carbon dioxide is leaving the body tissues going into the blood. So that's how come blood is getting deoxygenated now, and then it will be brought back to the heart through what is called the right atrium. It's going to go back to the heart. Okay, now this vein here is called the vena cava. Okay, so basically we can see that what is happening, blood going to the lungs and back to the heart, that is pulmonary circulation. Okay, this is pulmonary circulation. And then blood leaving the heart going to all parts of the body and coming back through the vena cava to the right atrium, that is called systemic circulation. Okay, systemic circulation. So we have pulmonary circulation and systemic circulation in the adult circulation, right? Okay, so basically you can see the path that is followed by blood. If we are to start is from the right atrium. The right atrium pumps, I mean the right ventricle pumps blood through the pulmonary artery to the lungs for oxygenation. Okay, and then from the lungs, blood comes back to the heart through the pulmonary vein into the left atrium, and then the left atrium pumps blood through the left ventricle, which later pumps blood into the aorta to go to all parts of the body, to the body tissues, where now deoxygenation is going to take place. That is, oxygen diffuses from the blood into the body tissues. That oxygen is going to be used up to form energy and carbon dioxide as a byproduct. That carbon dioxide is now going to diffuse back into the blood. Okay, and then that blood which has now received the carbon dioxide has to go back to the heart through the vena cava to the right atrium. From the right atrium, it goes into the right ventricle, and the whole process continues. Now, in fetal circulation, right, as we are talking about fetal circulation, so this is adult circulation. Now, I want to talk about fetal circulation. Now, the difference here in terms, between fetal circulation and adult circulation is that the lungs in utero of the baby in utero, within the uterus, when the baby is still in the uterus, the lungs are non-functional. All right. Basically, the lungs are not working; they're not doing anything. So there is no need of blood going to the lungs. Okay, blood should not go to the lungs in a baby who is still within the uterus. Why? Because the lungs are not working. Why? Because the baby is not yet breathing on its own. It's not yet outside the uterus, so it can't breathe on its own. So what is the option? What should happen? Right? So that is what now what we want to look at. That's what we want to concentrate on. How does the baby carry out? How is gaseous exchange done in a baby? All right. So the systemic circulation basically it doesn't differ so much. Okay. But of course there are a few differences here and there. But that's what we want to try and explore. Okay. So let's try to look at a baby. All right. Let's try to draw a baby here. All right. There's the out the baby, the nose, the mouth. Okay, both baby are very good. Okay, so let's try to draw the heart. So you can see here we have the heart, right? So probably let me try to draw the lung space. Okay. Alright, so here we can control okay, so at this point I'm going to try and use root. And this one I'm going to use loop. Okay, so normally this is what we have, all right? So like we said, we have um, the capillary bed here, okay? We have where all body tissues are. So blood enters into the right atrium and then to pump into the right ventricle, we pump blood to the lung for oxygenation. Then the lung blood comes back to the heart through the pulmonary vein into the left atrium and then the left ventricle, then to pump out through the aortic organs of the body. Now, in a fetus like we have mentioned, the lungs are not functioning. And so what is happening? So let's try to draw these organs a bit more independently so that we can appreciate what is happening. So we have the lungs. So let me draw the heart in a bit bigger version. Okay. Right. So let's now start following up what we are trying to do. Okay. So here we have, let me now use red to represent the iota. Okay. So this is the iota here. Next, the arch of the iota. Because here we have those little branches and so on. Right? We have red branches and then the iota comes down. Now the iota, the abdominal iota specifically, it will make two branches, that is the left and right common iliac artery. Okay? The left and right common iliac arteries, and then the left, the right common iliac artery, whether divided, okay, like that. So is the left common iliac artery. So now, at this point, we have what is called, this one, we have what is called the left internal iliac artery. And here we have the right internal media artery. Okay. Now, the other thing that we have is we have the vena cava. Okay. So we have the vena cava here. We try to build this down. So we have the vena cava here. Okay. Which is of course the inferior vena cava. In this case, I'm only showing the inferior vena cava. Okay. So here we have abdominal aorta. And then here we have the inferior vena cava, right? The inferior vena cava. And then at this point here, we have the pulmonary artery. Okay, pulmonary artery, which of course will branch into the right and the left pulmonary artery. Okay, one taking blood to the left lung and one taking blood to the right lung. And then also have, pulmonary vein, sorry. And then also have the pulmonary artery here, one taking blood to the right lung and one taking blood to the left lung. Okay. So this is the pulmonary vein, okay, and then we have the pulmonary artery. So of course it will branch into the the right pulmonary artery and the left pulmonary artery. So the vein has well the right pulmonary vein and the right pulmonary vein. Now the key here that I want us to take note is that between the pulmonary artery and the aorta, there is this connection here. Okay, there is a connection. Alright? And this connection is called the ductus arteriosus. Okay? That connection between the pulmonary artery and the aorta is called the ductus arteriosus. The other thing that we should take note is that there is also a connection, okay, there's a connection between, there's a hole between the right atrium and the left atrium. I'm going to try so there's a connection there. And of course there's a valve, there's a little valve in between that intra-atrial septum, right? So that valve is called the eustachian valve, right? So now that eustachian valve, it actually closes like this, okay? So it opens like that and closes like that. So let's see what is happening at this point. So what happens is that when blood is when blood comes from the, of course we're going to discuss further what is happening inside, but let's discuss what is happening in the heart. Okay? So when blood is coming into the right atrium, okay, when blood enters the right atrium, what is going to happen is that some of it, okay, so in fact, where the eustachian valve is at this point here. Okay, there's a eustachian valve just at the point where the vena cava joins the right atrium. There is what is called the eustachian valve that actually directs oxygenated blood. Okay, it directs oxygenated blood into what is called the the foramen ovale. So this connection between the right atrium and the left atrium is called the foramen ovale. Okay. Now, so we see that blood is coming in here, and then some of it is going to go, is going to shunt, it's going to go into the left atrium, and some of it will go into the right ventricle. So let me try to represent it this way. So some of the blood goes like that, and mixes the blood coming this way, and then of course it come into the left ventricle. Okay. However, some of the blood again will still come down like that into the right ventricle, and it will be pumped out through the pulmonary artery. Now, what is happening is this. I want you to get to point. In the belly, okay, within the uterus, intrauterine life, the lungs now are non-functional, and because of that, the lungs are compressed, and the blood vessels, okay, rather the pulmonary vessels, they are constricted. Okay, pulmonary vessels are constricted, and so blood is finding it very hard to push to get to the lungs. Okay, so because of that, blood starts looking for option where else to go because there's so much resistance. There's increased peripheral resistance. There's increased resistance within the pulmonary circulation. So because there's so much resistance, blood starts to look for option where else to go. All right. So blood is being trying. The heart is trying to push the heart through the pulmonary artery, but within the pulmonary artery, in the lung, pulmonary circulation, there's so much resistance. So blood has to find elsewhere to go. It has to shunt and go elsewhere. So where else is it going to go? There is this opening here called the ductus arteriosus. And so this blood that has been pumped through the pulmonary artery, it's going to find itself back, okay, onto the left side of the heart, and it will go into the aorta. All right. So let's go through that again. So we have blood. We're going to discuss what is happening here, but we're starting from a point where blood enters the right atrium. At this point, blood has two routes. Okay, when blood just enters the right atrium, it has two routes. The first route is that some of it is going to go into to the left side of the heart through what is called the foramen ovale, which is a pore between the right atrium and the left atrium. At the same time, some of the blood is still going to be pumped down into the right ventricle, and the right ventricle, of course, does its job and pumps blood into the pulmonary artery. Now, in the pulmonary circulation, because the lungs are non-functional, there is no oxygen there, there's so much pulmonary circulatory resistance. There's resistance there. So what happens then? Because of that resistance, blood has to find other routes, other channels. And one of the channels that blood is going to find is what is called the ductus arteriosus. Now, this ductus arteriosus is a connection between the pulmonary artery and the aorta. So blood is going to be shunted from the pulmonary artery and get into the aorta so that it mixes with blood on the left side of the heart. So already we can see that there are two parts, or rather 2 points at which blood is shunting from right to left. So in fetal circulation, we have what is called right to left shunting of blood. Okay, the reason is very simple. Blood should not be allowed to go to the lungs because the lungs are not working. The body is not breathing on its own. So there is no need of blood going to the lungs. Okay, blood should not go to the lungs because the lungs are not working, and so blood has to find itself going to the left side of the heart, which does not take blood to the lungs. Okay, so these are the 2 points: the ductus arteriosus and the foramen ovale. The foramen ovale is the connection between the right atrium and the left atrium. The ductus arteriosus is the connection between the pulmonary artery and the aorta. Okay, so blood comes from that. Now, if we are saying that the lungs in a baby within the uterus are not breathing, how is the baby getting oxygen? Now, this is where it gets interesting. Okay, so imagine this is the uterine wall. Okay, specifically, of course, the upper segment, right? So we have the wall of the uterus. Okay, so this is the wall of the uterus, and of course the endometrium, right? So this is the endometrium, and then we have what is called the placenta. Okay, so we have what is called the placenta. Okay, and then this placenta is connected to the baby. Alright, connects the baby through what is called the umbilical cord. Okay, I'm not going to do it so long. Now, this umbilical cord, it has 2 veins and 2 arteries. Okay, there are 2 veins and 2 arteries. I mean, it has 1 vein and 2 arteries. So here is the vein. I'll draw it in red. Shortly, I'll show you the reason why the vein is in red. Now, somewhere here, let me try to draw the river blue. I mean, in gray. So we have the river here. Of course, the river makes much sense to draw it in gray, but yeah, the sake of understanding in the river. Okay, so this umbilical vein passes through the liver. Okay. It passes through the liver and what is called ductus venosus. Okay. And then from there, we have it emerges from there and joins the inferior. Okay. So this is the umbilical vein. We have the umbilical vein here. Right? And then we have 2 umbilical arteries. Here is 1 and another. We are saying that these are umbilical arteries. Okay, so the umbilical arteries, okay, they are branches, rather they branch from the internal iliac artery. So one is coming from the left internal iliac artery, like that, and another one is coming from the right internal iliac artery. All right. Now, at this point here, what is happening is we have capillaries within the placenta and we have capillaries within the wall of the uterus, rather from the maternal circulation, right? So let's try to do something like this. So this is a capillary, the maternal capillary. Okay, And then we also have the fetal capillary. This is the fetal capillary. Okay. Now we should understand that we have these red blood cells. Okay, now, so there is something different about red blood cells in the maternal blood and red blood cells in the fetal blood. And there are these two main things that that make it different. Now, in the maternal capillary, compared to the fetal capillary, or rather blood, there is less hemoglobin than the fetal blood. Okay, so fetal blood has more hemoglobin. Now, remember the function of hemoglobin. Hemoglobin, what does it do? It attracts oxygen. It has a high affinity for oxygen, right? So meaning that the more hemoglobin someone has, the more capacity their blood has to carry oxygen, okay, which is needed by the body tissue, right? So because the fetal blood has more hemoglobin, it means that the oxygen that is passing through the maternal blood, the maternal circulation at this point here, okay, the oxygen that is passing through at that point is going to be attracted, okay, it's going to be attracted into the fetal circulation. So blood from the maternal capillary bed is going to diffuse into the fetal capillary bed. Okay, so that's why you see that here you have the umbilical, the umbilical arteries here. Okay, they are coming, they are bringing the oxygenated blood. Now, the same way, remember what we discussed here. The same way the pulmonary artery carries the oxygenated blood from the heart to the lungs. It's the same way you have these umbilical arteries carrying the oxygenated blood. Now we're going to understand how it is oxygenated. Carrying the oxygenated blood from the lungs, okay, and bringing it to the what? To the placenta. Okay. So now, here, what has happened? We can see that blood, okay, there's that exchange of oxygen between the maternal blood and the fetal blood. At the same time, carbon dioxide is diffusing from the fetal blood into the maternal blood. Okay, so that's how come blood of the fetus gets oxygenated at this point and then gets into the umbilical vein. Okay, which pass through the liver and then go to the what? And then to end up going to the vena cava. Now, let's look at this. Remember, the vena cava is carrying the oxygenated blood, right? The vena cava is carrying the oxygenated blood that is coming from upper to the body. So at this point, it means that we are going to have a mixture of oxygenated blood, the oxygenated blood and oxygenated blood within the vena cava. Okay, so we have a mixture. Blood that is entering the heart into the right atrium is a mixture of oxygenated blood and deoxygenated blood. Why? Because there is some of the blood that is coming from the inferior vena cava, or rather from the vena cava basically, to put it so, okay, which is bringing blood from all parts of the body. And then there's also blood that is coming from the placenta, carrying oxygenated blood. So I'm going to have oxygenated blood and deoxygenated blood. Okay, so at this point, this is why we're saying that there's a valve here called the station valve that tries to direct oxygenated blood into the foramen ovale. Okay, and then what else? Much of the deoxygenated blood is going to go down into the right ventricle. Okay, so from there, blood goes back and blood that is going into the right ventricle will be pumped um, into the pulmonary artery that we have already discussed. So now, at this point, on the left side of the heart, okay, remember the lungs are not working, and so there's no blood that is coming there's no blood coming from the pulmonary vein. Okay, we don't have blood coming from the pulmonary vein. So the only blood that we're having entering the left atrium is that one which is shunting from the right atrium going to the left atrium. And then that blood, which is oxygenated, will come down into the left ventricle. Okay. Then it will pump out into the aorta. Now remember again we said that this blood, which is deoxygenated, right? The deoxygenated blood here has nowhere to go. It's not going to the liver, to the lungs. It won't go to the lungs for oxygenation. So it still has to find itself back into the placenta where oxygenation is occurring. So that's how come we're going to end up now having, in this same aorta, we're going to have oxygenated blood and deoxygenated blood. So when blood is coming down into the abdominal aorta and so on, that's where now we're going to have some of the blood will continue and then go to the body tissues and so on, and then some of it will go to the placenta through the umbilical arteries. You go to the placenta the same way blood leaves the right atrium going to the lungs. So blood in this case from the internal and the left and right internal iliac artery, there's going to be these branches which are the umbilical arteries taking blood to the placenta, and then oxygenation occurs from there. Once oxygenation has occurred, the umbilical vein will take up that blood and pass through the liver and then go to the inferior vena cava. From the inferior vena cava, now we're going to have a mixture of oxygenated blood and oxygenated blood entering into the right atrium. Okay, so basically this is fetal circulation. Now, something interesting here. When the baby is born, and then we are going to have that cut. Okay, when the baby is born, you cut the umbilical cord, right? Of course, you clamp at this point. You clamp here. You also clamp there, and then you cut. Okay, you cut there. So meaning that blood will no longer be able to reach the placenta. The baby is no longer able to breathe through the placenta. Okay, it's no longer able to go to the placenta, and blood from the placenta is no longer able to go to the baby, rather to the heart. So now what happens? That is the point where once the baby is born, okay, it will inhale the first breath, all right, the first air, it will breathe in, and then the lungs are going to be deflated, and oxygen starts going to go into the lung, and gaseous exhale starts to occur. Now, that process, that moment, what happens? The blood vessels in the lungs, all right, the pulmonary circulation is going to dilate. There's going to be dilatation there, all right? There's going to be dilatation. Once dilatation occurs, or rather relaxation of those blood vessels, it now means that the resistance that was there in the lungs, there's no more resistance. Okay, number one, there's no more resistance. Meaning that blood does not need to start looking for where else to go. Remember at this point we said that because of too much resistance in the lungs, blood has to start looking for where else to go and finds itself going into the ductus arteriosus, right? So it no longer has to find where else to go. It no longer has to pass through the ductus arteriosus. Okay, now, so the pulmonary artery or the pulmonary circulation is now free. There's no much congestion, and blood is free to go to the lungs. Okay. The other thing that happens is that because now we have closed here, all right. Because we have closed, because the umbilical arteries are now obliterated, now closed. It means that there is now a resistance,
okay, in the arterial circulation, in these umbilical arteries, even in the aorta, and so on. And so, what happens also is that there is going to be resistance now on the left side of the heart. I mean, on the in the aorta and the umbilical arteries. Okay, so because of that resistance, what happens? Remember, I mentioned that this pyramid of value, there is some sort of a gate there that is going to close because when blood is flowing this way, the gate opens. But when blood is flowing in the opposite direction from the left to the right, that gate has to close. And so, the moment there's increased pressure on the left side of the heart, okay, once the baby is out of the uterus, there's going to be more pressure on the left side of the heart, and so that gate is going to be closed, and blood is no longer able to pass from the left through the foramen ovale, unless this foramen ovale was too big. Okay, if it was too big, then it is going to relieve what is called a patent foramen ovale, even after the intrauterine life. Okay, and it's going to remain resistant. So, what are we saying? Because of that resistance in the aorta and in the umbilical arteries, okay, there's going to be corrosion of that open that valve there, and blood is now able to pass to the aorta and then comes down like that. Okay, so um, with time, within 3 to 4 days after birth, okay, you see that this is going to muscles are going to start forming there, even fibrous tissue. But within about weeks or months, this ductus arteriosus, okay, is going to completely close. All right, it's going to completely close unless if it persists, then we have what is called a patent ductus arteriosus, okay, which is a congenital abnormality. Right. So this is fetal circulation. I hope you have understood something. I hope you got something from these concepts that we have tried to explain. Okay. So please again remember to subscribe to the channel and also like the video. Thank you so much. Until next time.